All right. Today let's solve Leetcode 435, non-overlapping intervals. Basically, we've been given intervals, and this interval may or may not be overlapping. If they are overlapping, find the intervals, the minimum number of intervals you need to remove to make these intervals non-overlapping. And the first example we've been given here is, let's take a look at the first example, which is 1 2 2 3 3 4 and 1 3. Right, so just by looking at it, we can see that 1 3 is overlapping with 1 to 2 and 2 to 3. And if we remove 1 to 3, none of these will be overlapping. But let's also take a look at, let's represent it on a number line. So say we have 0 here, 1 2 3 4 5 6. So 1 2 3 4 5. Right, so we know this is 1 to 2. Let's represent this here, 1 to 2. Now we also have 2 to 3, right? So we have, let's present it here, 2 to 3. And then we have 3 to 4. So we have 3 going up to 4. And then the last one is 1 to 3. So the last one is 1, 2, 3. So let's take a look at that. 1 goes all the way here and goes to 3. Right. So clearly we can see that 1 to 3 consumes all of this. And if we take that out, we would have 3 non-overlapping. So that's the minimum we can do. We can remove this and that, and then all of it will be non-overlapping, but that is the maximum, right? But we want to take out the minimum. So this is something. This is the graphical representation of it. So when we start with 1 to 2, 1 to 2 ends here. The next one we pick is 2 to 3. We know they don't overlap because the end of the first one is the beginning of the next one. And then we come here, 3 to 4, the end of this one is the beginning of the next one. Then we have here the end. Then we come here, right, the last one. The end of this one is greater. The end of this one is greater than the beginning of this. So that makes it overlapping, right? Because we are already here, and what we are picking up is starting from here. It's less than this one. But this has all of this here, and clearly all the time I'm saying the end. So it will be best if we sort it by actually the end values, which will be, so red will be 1 to 2. If we sort it by the ends, right, 1 to 2, and then we sort, the next one is 2 to 3, the last one is 1 to 3. So let's get the green one, that is 1 to 3. And then the next one will be 2 to 3. And then the last one will be 3 to 4. So here the end, which is 2, is greater than the beginning. There is an overlap here, right? So we are here and this one is starting from here, so immediately we know that we need to take this one out. And then once we come here, that this one, which is 2, it is greater or equal to, so we see a 2 here, and then we continue and all of that. But how do we even know the stats, right? So let's say the start here is a stop. Call it stop. Because the end here is greater or equal to the stop, we know that there is non-overlapping. But when we come here, which is the second one, the end is greater. You know, the end must be less than, right? So for example, here the stop, this is the stop 1. If this is the start is less than or equal to the stop, right? If the start is greater or equal to the stop, they are non-overlapping. So after that, if we agree on that, which means that the next stop should be here, so stop 2. But stop 2, the start of whatever is coming should be greater or equal to stop. But that is not the case here, so we detect that this is an overlap, and then we have to take this out, right? So always start must be greater or equal to stop. And how do we represent it? Because this question accepts both negative and positive stop, we initialize at negative infinity, right? So starts must always be greater than or equal to stop, else stop, no, if start is greater or equal, then stop now becomes end. So if this is the case here, stop now becomes end, stop now becomes end, and then we move stop here, stop, so eventually stop will come here, stop 3, and then the last stop will be here, stop 4, right? So start must always be greater or equal to stop. So let's look at how we are going to solve this on Leetcode. So first we initialize our stop. So let's do our stop, which is equal to a negative infinity. And then let's set our results is equal to 0. One thing we must also do is initial sorts the intervals by the ending values. So intervals dot sorts key equals lambda for x, the second value, right? Now let's do the implementation for starts and in intervals. If starts is greater or equal to stop, if the start is greater or equal to the stop, right, the stop now becomes the end. Else, so we start from first stop. If this one, we come to stop 2, right? Now we are going to pick the second one because we've sorted. We are going to see that the start of this 1 to 3 is less than stop, which makes it something that we need to take out, right? Else results is increased by 1 because it's an interval that we need to remove, and then we return results. So yeah, this is how you solve non-overlapping intervals. Let's see if this is correct. All intervals. I missed an S on intervals. Yes. So yeah, that is how you solve non-overlapping intervals. Thank you for watching. See you in the next one.